From Cape Canaveral Air Force Station in Florida, you're watching live coverage of the launch of the SpaceX Falcon 9 rocket and Dragon capsule from Space Launch Complex 40. This is Falcon Launch Control at T-minus 1 hour, 34 minutes, and counting. On this date in history, 54 years ago, October 7, 1958, America's fledgling human spaceflight program officially received its name, Project Mercury, and a new era began. Tonight, October 7, 2012, another new era begins, and a new history will be made. America's first commercial resupply services rocket is poised for liftoff from Cape Canaveral Air Force Station, the same facility that launched the Mercury missions and began the era of American human spaceflight. The SpaceX Commercial Resupply Services 1 mission will return to American soil the launch of cargo to the International Space Station. Liftoff of the SpaceX Falcon 9 rocket and Dragon capsule is scheduled for 8:35 p.m. and 7 seconds Eastern Time. At liftoff, the Falcon 9 will head northeast at an inclination of 51.6 degrees to the equator to match the International Space Station orbit, its destination in 3 days. This mission, designated SpaceX CRS-1 for Commercial Resupply Services 1, will be the first of 12 contracted flights by the company to resupply the space station. Under the CRS contract, SpaceX will restore America's capability to deliver and return significant amounts of cargo, including science experiments, to the space station, which is a capability that has not been available since the retirement of the space shuttle. The Dragon capsule is filled with about 1,000 pounds of supplies, including critical materials to support the 166 investigations planned for the station's Expedition 33 crew. 63 of these will be new. Equally and possibly more important, Dragon will return with about 2,000 pounds of cargo, including 734 pounds of scientific materials from human research, biotechnology, materials and education experiments, and about 504 pounds of space station hardware. The piece of orbital debris that was discussed during Saturday's pre-launch news conference has been reevaluated and is not a concern, so there will be no need for the space station to perform a debris avoidance maneuver. So at the time of launch, the space station will be exactly where we thought it would be, flying at an altitude of 255 miles southwest of Tasmania. Leading up to this evening, SpaceX successfully completed 2 demonstration missions using Falcon 9 and Dragon under NASA's Commercial Orbital Transportation Services Program, or COTS. The second of those missions, in May of this year, marked the first time that a private company had launched a spacecraft into orbit, successfully attached it to the International Space Station, delivered a payload, and returned safely to the Earth, something previously accomplished only by spacefaring governments. There are no technical issues. Everything has been progressing well through the countdown. Weather is 60% favorable. That's the prediction for the time of launch. Mike McAleenan, launch weather officer from the U.S. Air Force 45th Weather Squadron at Cape Canaveral Air Force Station, is briefing the launch director and launch controllers and keeping everyone apprised of the weather in the area. The concern has been for thick clouds and anvil clouds and the potential for Dragon and Falcon to fly through precipitation. Those are flight rules that we would not want to violate. The prediction has been that we would have a 60% chance of making it at the exact time of liftoff. And so far, things look good. There will be a weather briefing at T-minus 1 hour, at which point Mike McAleenan will update the weather, and we'll see if he will revise the forecast at that time. We're at T-minus 1 hour, 29 minutes and counting, and in a moment we'll have an interview with International Space Station Program Manager Mike Suffredini. To be joined by Mike Suffredini, the International Space Station Program Manager. Mike, thank you for joining us.
My pleasure. Thank you for having me.
It's a great time as we get ready for the first commercial resupply services mission to the space station with the SpaceX Dragon and Falcon. Can you tell us what this means for the International Space Station?
Well, it's really critical. We've been talking about this a lot lately. What station was built for is to do research. And if you look at the research we've done in the past, even during assembly, it's been quite incredible. I mean, there are drugs for dispensing cancer treatments, specifically the tumors themselves. There's hope for a salmonella vaccine. There's a number of things going on in the station already. So what this commercial resupply capability is going to do for us is give us a consistent supply chain. And not only is it going to give us a consistent supply chain up, but very critical, particularly to biological type research, is the return mass, to be able to have frozen samples returned home, which is very critical for us. So this really is the cornerstone or the keystone to what is going to allow Space Station to do what it was built to do. So not to be over dramatic, but it's critical to the success of the station.
Is that return capability one of the things that distinguishes the Dragon from Progress and ATV and HTV and some of the other?
Correct. The only other vehicle that returns anything is the Soyuz spacecraft, which returns people, but it also returns a small amount, maybe 50 kilograms, and they're all kind of stored in special spots. So it's hard to bring a big component home. They get stuffed under the seats or in special locations. And so you don't have as much flexibility. And being only 50 kilograms, of course, that's kind of limited.
The mission profile after launch, can you tell us a little bit about what happens to Dragon on its way to the space station?
It does a number of maneuvers to get itself into an orbit. It actually enters an orbit that's about 325 by 200 nautical miles. Then the Dragon's going to separate, and the second stage will go on to do some secondary payload work. The Dragon will work its way up towards ISS's orbit over a period of about 63 hours, and then capture will occur at about 6:23 a.m. Central Time on the 10th. So it's got kind of a long journey to slowly catch up with the ISS. But what we won't do is everyone kind of watched last time. We had a number of demonstration objectives, and make sure the far field and near field navigation systems work, which resulted in an extra day where we went around after testing some systems. We flew around a track pattern, came back to the ISS. All of that will not be necessary this time, so it'll just come directly to ISS to be berthed.
And we have about 1,000 pounds of cargo going up and about 2,000 pounds coming back down?
Correct. And the 1,000 pounds going up, as I talked about earlier, one of the advantages to having an indigenous capability is it's very easy to make decisions when a failure occurs on orbit to say, okay, this spare now is more important to me than something else was on orbit. On the flight, and so you can work with the SpaceX in this case, and we did that. There was a pump that supports the urine processing assembly that we decided after it failed on orbit, and we consumed our last spare, that we really thought we needed a spare on orbit a little sooner than the one that was going to be brought up on ATV-4. And so we were able to make that kind of adjustment. So that's in the 1,000 pounds going up, and of course in 2,000 pounds going down. We have an active capability now. Actually, it's going to be utilized going uphill as we mentioned before, to take up a number of things, including the infamous ice cream now that we've been talking about. But also those same freezers, perhaps more importantly, will begin the process of removing the samples that we've been storing on orbit. We've been doing research without shuttle there. We've been doing research ever since the last shuttle mission and filling up our freezers on orbit. And so this will be the first flight where we're able to start returning those samples that are starting to be collected on board station. It's very critical for us to get caught back up and get those samples down to the ground where we can work on them.
A lot of traffic to the space station. That's nothing new. It seems like over the last several years with all the visiting vehicles, that's been the case. Can you give us a little flavor of what's coming up the rest of the year?
Absolutely. So we have the SpaceX vehicle coming up, which we're fitting in before the Soyuz flight that's going to bring up the next 3 crew members to the ISS. And that launches on the 22nd of October and docks on the 24th of October. In the end of October, then we have a 49 Progress vehicles, so Progress vehicles flying to ISS. Today we have scheduled the Sunny Aki and Yuri will return on the 12th of November. And then in late December the 19th, we have the next Soyuz going up which will fill out the crew back up to 6 at that point. There was on the manifest a orbitals demo flight, and that's going to end up going into the next year sometime.
Okay, and in there also we have the return of the Dragon.
Absolutely, that's right. Today, and that's one of those flexible things you work on. Today, it's planned for the 28th. When we get to orbit, depending on how things are going, we might adjust that a little bit. But you're right. Today, the plan is for them to return on the 28th of October.
All right. Thank you, Mike.
You bet. Thank you.
This is Falcon Launch Control at T-minus 1 hour, 21 minutes and counting. All systems are go. Weather remains 60% favorable as we approach liftoff time at 8:35 p.m. Eastern Time. A lot has gone into the processing and preparation for tonight's launch. Several months before launch, both Falcon 9 rocket stages and the Dragon were transported to SpaceX's development facility in McGregor, Texas for testing, and then they were trucked individually to the SpaceX hangar at Space Launch Complex 40 at Cape Canaveral, Florida here, where the stages were integrated and Dragon was loaded with its cargo. On August 31st, SpaceX conducted a wet dress rehearsal of Falcon 9, which simulated the launch countdown and verified that all the ground and launch systems were launch ready. The final major pre-flight test recently, September 29th, was the static fire when Falcon 9's 9 first-stage engines were ignited for a few seconds while the vehicle was held in place, and that was successfully performed. About 2 weeks ago, a formal stage operations readiness review was conducted involving representatives from all 5 of the space station's international partner agencies, NASA, the Canadian Space Agency, the European Space Agency, the Japan Aerospace Exploration Agency, and the Russian Federal Space Agency, or Roscosmos. This was to ensure that the launch vehicle, the spacecraft, cargo, the International Space Station, and the launch and operations teams were ready for the mission. Another milestone passed, and we moved forward to delivery of the rocket. Last night, following a slight weather delay, Falcon 9 with Dragon mated was again rolled out to the launch pad. That was accomplished at 9:55 p.m. and Falcon 9 was elevated to the vertical position for launch at 1 p.m. today. As we've progressed through the countdown this evening, Falcon 9 and Dragon have been powered up, the systems activated, the computers turned on, and a little less than 4 hours before launch time, the fueling process began. Liquid oxygen was loaded first, and then RP-1 propellant, which is rocket-grade kerosene, loaded on to Falcon 9. The plume that you see coming off the vehicle is gaseous oxygen, which is being vented from the tanks, which is why the liquid oxygen is topped off throughout the entire countdown. The first motion test was performed at T-minus 3 hours and 30 minutes. Tests of the C-band radar and S-band telemetry system passed. That was accomplished at about T-minus 3 hours. And about an hour ago, the flight termination system checks were performed. Everything is going well. The terminal countdown will begin at T-minus 10 minutes and 30 seconds, at which time all systems will be autonomous. And after polling mission control in Houston, Texas, and the launch team in Hawthorne, California, Launch Director Brian Mosdale will give a go for launch at T-minus 2 minutes and 30 seconds. At T-minus 2 minutes, the Air Force Range Safety Officer will confirm the safety of the launch area and the eastern range. And 1 minute before launch, the flight computer will be activated. "55 seconds before liftoff, the launch pad's water deluge system, which is dubbed Niagara, will be activated. It suppresses the acoustic waves that radiate from the engine plumes to counter the effect of vibration on the rocket. There are 53 water nozzles set low on the launch pad that will provide a curtain of water flowing at 30,000 gallons a minute. The system will be deactivated within 20 seconds of T0. 3 seconds before launch, the 9 Merlin engines of the first stage will ignite, and at T0, the rocket computer will command the launch mount to release the vehicle for flight, and Falcon 9 will lift off, putting out 855,000 pounds of thrust. That will set Dragon on its way to the International Space Station for an arrival on Wednesday. Flight engineer Aki Hoshide will grapple the Dragon, and Station Commander Sonny Williams will berth it to the station for an 18-day visit. Dragon is scheduled to return to Earth on October 28th, and it will splash down about 250 miles off the coast of Southern California under 3 red and white parachutes. At T-minus 1 hour, 16 minutes and counting, this is Falcon Launch Control. This is Falcon Launch Control at T-minus 1 hour, 10 minutes and counting. There are no technical issues of major consequence being worked. Weather remains 60% go for launch. In about 10 minutes, Launch Weather Officer Mike McAleenan will brief SpaceX Launch Director Brian Mosdell on the status of the weather. We're looking at the satellite view right now, and it appears as if the boundary that has been making its way toward Florida over the last few days is continuing to slowly make its way. We were hoping for a little bit more speed and that it would clear through the area before the time of launch tonight. It, in doing so, would leave us with drier air and more favorable weather conditions. But as it is on the radar, it looks as if the system to the south is breaking up. There is rain forming in the area and encroaching within the 10 nautical mile circle, which would present a launch violation. But we still have more than an hour prior to launch, and hopefully things will clear up. The major concerns are for rain in the area through which Falcon would have to fly, as well as thick clouds and anvil clouds. At the time of launch, the temperature is forecast to be 78 degrees with 82% humidity, 7 miles visibility, and then 3 layers of clouds, a scattered base at 4,000 feet, broken deck at 10,000 feet, and a broken deck at 25,000 feet. Again, there is some optimism that weather is going to cooperate with us, and we'll have an official weather briefing in about 8 to 10 minutes. This is Falcon Launch Control. This is Falcon Launch Control at T-minus 1 hour, 3 minutes and counting. And for residents on the Florida Space Coast, there's a possible sighting of the International Space Station coming up at 7:37 p.m. Eastern Time, about 6 minutes from now. The pass is expected to last about 3 minutes. The station will be at a maximum elevation of 15 degrees, approaching from 10 degrees above south-southeast, and departing about 13 degrees above east-southeast. We're standing by for a weather briefing from Launch Weather Officer Mike McAleenan. He'll be briefing the launch team on the forecast through the remainder of the count and at the time of liftoff at 8:35 p.m. and 7 seconds. That weather briefing should be coming up momentarily. And to make a correction to something that we stated earlier, the upcoming Soyuz launch during this busy month of October is scheduled for October 23rd. And Soyuz will dock to the International Space Station with more crew members on October 25th. Again, we're working no technical issues of any major significance for Falcon 9 and Dragon. And weather remains 60% go.
This is the LWO with the L-1 hour range weather briefing. Looking at your video on the satellite picture, you can see a infrared picture with west coast sea breeze moving across the peninsula of Florida at a very fast rate, creating a lot of showers and thunderstorms inland today, much different than the previous days where most of the activity was on the east side of the peninsula. This infrared picture does overstate the conditions outside. If you look at the radar set to 0 decibels to get cloud edges, you can see much less coverage over our area. Looking at an anvil cloud that has moved within 10 miles or so of the launch complex, has not violated any of the rules for range safety or with the 15 dBz precipitation in that anvil, any of the flight through rules for SpaceX and Dragon. Also looking at some showers to our south and east, about 30 miles or so, the tops of which would only be a concern if it moved over the launch pad, which at the timing of its current movement would be an hour after launch. Looking at the conditions at the launch complex at this time, winds are very light, 5 to 10 knots, and the direction has shifted around from southeast earlier this morning now to east-southeast again, for launch time. Temperatures are beginning to drop and nearing 80 degrees Fahrenheit. Right now we are forecasting a few clouds at the 4,000-foot level, also a few deck at 10,000 feet, and only scattered conditions, mostly that remnant thunderstorm anvils from inland thunderstorms at 25,000 feet. Visibility expected to be unrestricted and winds staying out of the east southeast at around 8 knots, dropping our overall probability of violation down to 20% with the favorable conditions that we're seeing on the east side of the Florida Peninsula today. Right now we are tracking all go conditions for range weather launch commit criteria, as well as Falcon 9 weather criteria. In the event of a 24-hour delay, conditions remain favorable with scattered conditions at the mid and low levels, winds out of the northeast at 10 knots, maybe a rain shower or two in the vicinity, but an overall 80% chance of no violations for launch time. For a 48-hour delay, similar conditions exist with the second or third day of easterly flow. Potential for a cumulus cloud violation exists with thunderstorms or potential rain showers just offshore rolling in. And again, but overall, just a 20% chance of that kind of condition existing. So overall, looking very good, tracking no weather issues with 1 hour to go. And that's all I have, pending your questions. LO out.
This is Falcon Launch Control at T-minus 56 minutes and counting. And good news from Launch Weather Officer Mike McAleenan from the 45th Space Wing Weather Office. He's improved our chance of a go weather forecast at the time of launch to 80%. 80% go with the east side of the Florida Peninsula clearing out of much of the clouds and precipitation that have been in the area for the last week. He indicated that anvil clouds that were noted on the radar are not violating any of the launch commit criteria. There are showers about 30 miles south and east of Cape Canaveral Air Force Station, and those would be a problem if they drifted within the launch area, but that is not expected until about an hour after launch. Winds are now about 5 to 10 knots. Just a few clouds, unrestricted visibility. Everything is looking real good for launch this evening. Again, our launch time is 8:35 p.m. and 7 seconds. That's for the launch of SpaceX, Falcon 9, and the Dragon capsule to the International Space Station. This is Falcon Launch Control. This is Falcon Launch Control at T-minus 50 minutes and counting. The Falcon 9 rocket, topped with Dragon, stands at Space Launch Complex 40 at Cape Canaveral Air Force Station, 157 feet tall, 12 feet in diameter, and its 9 first-stage Merlin engines will generate 855,000 pounds of thrust at liftoff at 8:35 p.m., increasing to nearly 1 million pounds of thrust as the Falcon 9 climbs through the atmosphere. Falcon is named for the Millennium Falcon in the Star Wars movies, and the number 9 refers to the 9 Merlin engines that power Falcon 9's first stage. Dragon is 14.4 feet tall and 12 feet in diameter. The trunk is 9 feet tall, and with the solar arrays fully extended, it measures 54 feet wide. And although this is a cargo resupply mission, the Dragon was designed to carry crew, and SpaceX is working hard toward that goal. Dragon was named for the fictional Puff the Magic Dragon character. T-minus 49 minutes and counting, and coming up next we'll be talking with SpaceX President Gwynne Shotwell. This is Falcon Launch Control.